What would that show you about its momentum if it rolled off the track? So are you measuring its speed or how far it rolls?
How far it rolls.
And so if it rolled all the way off the track, would you think...
What do you think? What do you think? If it rolled off the track.
So let's stop and have a quick conversation.
Somebody probably pushed it.
Maybe. What are your two variables right now? Can I have you sit up so that we're not moving our ramp? What are your two variables? There you go. What are your two variables?
Control and the two variables.
What are the variables, the things that we're looking at?
The mass and the distance.
Okay. So you've told me that the distance is going to help you to see the momentum. So using those two variables, what can you say about if it were to roll all the way off this ramp, what would you say about that car's momentum? Does it have a lot of momentum if it can roll all the way off?
Because if it's lesser weight, it won't go that far because it may be its mass right here, on here, but you can't, it's not mass, I mean friction on here.
Can you talk with your group members? I want to hear this, but can you talk with them?
It'll fight the friction more, and eventually it'll stop it. But it might roll up the track, that's what I think. I think we did it when we said, it's supposed to have no middle ground. Because we say current empty.
So take a look at how he's done this. So take a look. These numbers should actually be on this line, and those numbers should be on this line. So do you just want to move those numbers down? It's easy. So that not only was that a great question, but you had a really good answer to that question. So where are we going to go next?
We're going to do another tire.
Okay.
Just put one. Oh, yeah. One metal rod. I'm just checking off. Okay, It's 45, not 54. Okay, what do we got to do next? That's 44.
God bless you. Tickling you? So what are you doing right now, Jonathan?
I was adding it. And then I got
Why are you doing that?
I'll start to get at the correct. Right, tell me that thing.
Go.
Why do you think that's your opinion? And why?
So we kind of answered that question. I see that you have some good questions down there. Take a look at some of these questions that you have to kind of think about.
Which man has the most momentum so far? Why do you? I'll say. Why do you think so?
So let's stop and talk about that one first.
Because you have a rod in it, and that pushes it down faster. Like it faster.
So can I ask you again? What are your variables? Are you finding how fast it goes?
The mass and the centimeters.
The distance in centimeters? So when you look at this, when you're looking at its momentum, Jonathan, you said something about it going down the track. Are you looking at its distance or at its speed?
Distance.
Okay. So which of those had the farthest distance? Which of them had the most momentum? kind of tell me why? And could you talk to your group members about it?
I want to say the answer because if we added another metal rod, it's frictional here. So when we roll it down the rail, the metal rod is helping the car because it's fighting the friction. The friction is saying you're going to stop, and the car is saying I'm not going to stop. I'm going to keep on going.
What about the car is making it say that?
The metal rod.
And when we added the metal rods, what did that do? What did it change?
The distance.
It changed the distance. When we added these metal rods, what were we changing? Thinking about our other variable, what are these adding?
Adding mass. Right, inertia. You're adding mass. Right, what Donald was saying, because it put more weight on it. And so it make it heavier. And then it try to catch you and make you stop. And then these metal rods push you down. And it makes it keep on going faster and faster and faster. Wait. So, if it makes it go faster, if it's heavy, why does it make it should be stopping? You said what? If it's heavy, it should be stopping, not going faster. I know, but the rim, it make it go, so it make it go fast. But so if we just sit it like this, can you tell me it's not gonna go? It's not gonna go. But if we put it on the rim, then it's gonna start going faster down. And then it probably stop at something like 72, 172.
So is that how fast it's going or the distance that it's going? So also an answer to your question was you were saying, well, it should slow it down or make it not go as far with the weights. That's why we're doing this experiment. So based on your findings so far, looking at your means, which car actually has more momentum? Okay. Was there a decimal there?
Oh, no, never.
But good thing to check. So based on the two cars that you've done, which one actually has more momentum? The empty car or the car that was 104 grams? That's kind of an answer to your question too. What great questions y'all are asking. I want to challenge you to keep asking those good questions and talking with each other. I'll come back and check on y'all a little bit, okay? Proud of y'all.
I got a question. On our graph, we have we only got a 160. That's it.
Did something not go that far?
Yeah, we went to 157.
Oh, you know what? Okay. So let's take a look at these numbers, y'all. You have 171, 146, and 155. What do you notice about those numbers?
They ain't on the graph.
Okay, you're right. They're not on the graph. What do you notice about the difference in those numbers?
Can I see that these two are kind of close, and this one's way behind. Way far.
So
it's like.
Can you hold it for him so you can see?
It's like 20.
It's a very good estimate. I'll be with you in a second, okay? Can you scoot over so you can see that? Because that's a good thing to think about.
It's like 20 from 40. It's like 30.
I'm sorry, I didn't mean to sit in your way.
It's like 30.
All right, let's go ahead and take a look.
It's like 30. 30 numbers away from 7, and then this one is like 20 away from that.
So what does that tell you, Deontay? Remember that experiment that you did and the numbers had a large difference?
Yeah.
What do you remember about that experiment? Can y'all talk with each other about that?
I got a sheet. Also, what we did for the last one.
So now let me focus you back on my question. Let me focus you back on the question. Y'all are saying, you know what? These numbers are really far apart. Deontay, what
did it over.
Did you do it over?
Yeah, but I don't think we should do it over because it's all start with 1. And then we're going to have to do it over. We kind of had the problem,
okay.
But we solved it. So.
Was it a problem with actually measuring?
No.
Or was it a group problem that you worked through?
No. It was like the messed up. It was the messed up. Yeah, it was like he kind of knocked it over, but he fixed it first.
Okay, one thing that I'm noticing right now is that our roller is a little bit off of the ramp. So is that a possibility that it was accurate when y'all were doing it? So Deontay, can you come over here and sit down with us so that you can kind of talk with us? Because the problem that you're saying is that the numbers have a really big difference, Deontay.
But
So my question to you is, if this one went 171 and this second trial went 146,
redo the first one.
Juan was saying, Deontay, that's a pretty big difference. So is there a chance?
Takes 30 to get to this one. But force made it go. Momentum made it go farther. What's the word? Made it go faster. Speed. Friction. Friction made it stop at a certain point. But you was talking about speed and friction. Friction is stop, and speed it makes it go. Speed is like. Well, we ain't talking about speed. We're doing something different. We're using momentum. What's the difference? The difference that we're measuring.
So let's get back on this. And you're very right. So we're measuring the distance, Deontay. So when we look at this and there's this big difference, do you think that there's a possibility that there were some inaccuracies in that trial?
Yeah.
So if you see that big of a difference, let's just go back and redo it. Let's go back and redo that one, okay? So accuracy checkers, how many or how much mass does he need to have in the car?
One.
Okay, so Deontay, let's take our places back there.
I just let her use my eraser so she
That was cool. Okay.
Better?
I didn't mean to jump in your way. I'll get over here now.
Erase all of them.
Well, y'all decide. Do you think you need to do all of them again?
No.
You just gotta erase that and a million because
Yeah,
the million.
just erase that too.
What do Deontay think?
I think we should erase the math because I also got a question for all of us.
You mean the million?
I got a question for us, okay, y'all? Now listen, here's the question, and it says,
We not right there yet.
So let's go ahead and get our trial going so that we can find the mean and move on, okay?
we
Deontay?
do trial 1. We did trial 2 and trial 3.
You're right. So we're going back. And which car is it? What does he need to know about the car that we're redoing?
Hey, we're doing car B.
What did y'all decide to just read it?
The mean and the first trial. On the first trial.
So does he need to have any weights, any metal rods? Okay, here you go, Deontay. Okay.
First, you gotta make sure this.
Okay. Uh-oh. Wait, hold on. All right, now, there we go. Take a look at where he's got his car. So let's, hold on. So let's get our,
That thing slip.
push it together. There you go. Okay, now, there we go. Deontay.
Scoot it up a little more.
Look, no, Ross. I want you to hold on to it so you can let it go, okay? Hold on to it.
Then I'll watch it.
All right. Thanks for helping me, Tiandre.
Go.
Ah,
139.
That's good.
It's 100. When it was 100 because it won't pass that round.
But
The other ruler.
it only takes about like a few more to get to this one.
So do you think that's a little bit more accurate? It's a little bit closer to those?
Yes. But it'll just take 20 to get to this one.
Oh, yeah, because we started 40. 139.
Okay.
Yeah, it's going to the 30 to 40 to the 50.
Are they pretty close, though?
Yeah.
Yes.
Okay.
Like a connection. That's like the text.
So let me show you something.
Oh,
Let me show you something. 139 is right here, right?
Yep.
Okay. 155 is here. Is that a pretty big difference in...
No.
Is that a pretty big distance in how far it traveled?
No.
So can you see how far that is?
But look, 1, 2, 3.
It's not that much.
6, 7, 8, 9,
then you got
10,
100.
11, 12, 13, 14, 15, 16.
So,
But it wasn't like it was 20.
But y'all got this.
so y'all are saying y'all are happy with it? Okay, so
Now, do you mean?
Now I changed it like 20. Well, it's like a big over number. It's 16 and 10 like a pretty big number.
Okay, so we'll do the next one and see if.
What is that for me? The me.
Add up the total for me.
18, 19, 20. 50 now, we will have to do it.
Okay, so you think 20 would be too big of a difference? Okay. So what are you doing right now?
Divide by
The
3.
me.
Divide by 3.
I'm not finished.
Why are you doing that, Tiandre?
So you can.
So you can find the distance.
No. Yes. Yes. I got a question. Do we put equal and then divide by 3, or do you just put and then divide it?
So
It's going to be the same. You can either push equal or you can just go ahead and push divide. That's a good question.
then we can, if I can
See, this not on the.
Are you looking at Deontay?
This one not on the
So
graph
that's
either.
okay.
See, it goes up to 160.
Okay. So I tell you what, since that graph doesn't have the numbers, why don't we graph it after you finish finding all the means, and I can get you another graph. Okay?
So 1 46. That 6.
Wait, but I got a question. It has low numbers, like it has low numbers when we doing it, cause it didn't have low numbers. But like when we doing the graph, this one go to 6. I think it should be more low numbers.
You're right. So I'll get you another graph after we finish finding these means, okay?
Okay, do y'all want to do this one?
Do what?
Yeah, we was already starting and we answered that question.
Okay, cool. I'm sorry, I couldn't hear you, Tiandre. What did you say? Okay.
So, do y'all want to start this one over?
Yeah, no. I don't think so because it's not really a big difference. But like, we start doing all of it and then
Yeah, we should do the other one and see if it's like.
okay, so we gotta read. So we keeping it right. Okay.
Wait, up a little more.
So, Deontay, can I stop you for a second? Just so that we don't maybe have to do as many redos. Remember how I showed you to let it go? Can you come sit right behind here?
You sit. Well, you can sit on like this, like this.
That would be fine.
And
Okay.
then you.
So now, Tiandre, now you can get in there.
Wait.
And help me.
Wait. I see something. That it's like a little bit right there. Perfect. Oh no! No!
Well, take a look. Just move the ruler.
It's 100 and
Good thinking, y'all.
157. Now I think it should be 103 to 157. Nobody.
So, y'all want to start all of them over?
So
Oh,
we're not
good.
using a timer.
This typo.
I don't get it.
What don't you get?
Because this, it was on 100. But this, it's heavy and don't it contain it to like go slower?
What? Well, for this, look. But when we was using 3 bucks, that's what made it even slower. But since we using this, it's going to go faster than it usually.
What are you measuring?
The distance. That was 149.
Like we did on the last experiment.
Did we measure distance?
No, we
I mean, on the last before that last.
Oh, when you were doing the different surfaces? Yeah. So with this, Deontay, I see you looking at some.
Deontay?
Okay. We got you kind of tight over there. Now we. Okay, be careful there, buddy.
Sometimes you gotta watch out for what you're doing.
That's right.
At the guy, she said.
So why was it important for us to fix our experiment again now that it's kind of been toppled over?
Well,
Why would we
because
need
if we didn't, we wouldn't know because the ruler, they ain't way over there. And then it's still, we still looking. The number we'll know.
All right, so Lanaya, I'm sorry, back to your question. You had a question?
Oh, I was saying that I don't know. I don't.
Sit right here, then that won't knock anything.
I don't get how when it's heavier, it makes it go faster than when it's emptier. Because like sometimes on other stuff, when once it's getting packed up, it makes it go slow, and then when you don't have nothing in there.
So your question again is about its speed.